Wishing a very pleasant day for you all and Aibowan. Today's my presentation is the possibility of using soil concrete for modern eco-friendly housing. I am Himal Hikadua. So according to the Article 25 of Universal Declaration of Human Rights in 1948 says that everyone has the right to a standard living adequate for the health and well-being of oneself and one's family, including food, clothing, housing, and medical care and necessary social services. When we look onto our rural sector, this is the more common picture we can see due to lag in affordability of living in a good house. So when we stick and look onto the cost of construction of a house, the construction labor and material have the more share. When we look on to rural sector, labor is not a big issue, but material have a major issue. When we further go down, for the component cost share of the construction of a house, the second most is wall construction. From our thesis studies and the literature study, it was found that mud concrete block have a good life cycle cost. Then our objective is identify the most economical, sustainable, eco-friendly walling solution to housing sector with the use of soil concrete. This is the methodology that we were followed. First, we identify the different soil-based construction that are popular applications and compare the strength, weaknesses, and opportunity of those techniques, and find the best mixture of soil according to the available standards, uh, and also do a mock-up real scale wall and find the practical aspects. These are the theses that open us to use the soil concrete methodology. There are some studies already done by my another partner, Professor Halvature, Aryu Halvature. So one of the real scale model also tested there from soil concrete block in for the communities that are affected war victims in Betiklo district and other things. We know according to our soil map of Sri Lanka, laterites is freely available throughout the country. So we can use laterites as our raw material. There are, in the normally we have a lot of soil-based construction techniques available everywhere in the world, and also from our history we can learn how the soil performs in building or construction sector. When we look into the soil-based building construction, wattle construction is most popular in rural sector. Most of the houses are built from wattle, that is we call varichi. And then the adobe bricks or sun-dried bricks and laterite earth blocks and CSEB, compressed stabilized earth blocks, now in popular in the construction industry. And ram earth construction, this was popular in Europe and other countries, but not in Sri Lanka well. So we think to base this technology as our base technology. So these are the pros and cons of soil construction. Not durable enough, not strong enough to build a large scale building, usability issues, technology issues, thermal expansion. And other hand, there are advantages: affordability, easy to construct, eco-friendly, sustainable, biodegradable. These are found from our literature survey. And the proposed technology is based on the ram earth technology and laterite soil used as a raw material, and OPC or the ordinary Portland cement as used as the stabilizer, and the soil with soil concrete with light compaction, easy handling method. that we are used, and fair finish walling through slip form construction system, and cost effective low cost construction technology. So this is the one of the housing project in 2005 in Hikkadua, the tsunami housing project. These houses are still in good condition. These are built by Ram Earth. So this is another eye opening for us to develop this system. And we look into our study, the best mix. According to SLS 1382, we are tested using Atterberg limit test with the test cubes. So you know there are dry and wet compressive strength is there from those strengths. It is given that 30% gravel content give the good strength, and also less than 10 or 10% fines mixer give the better strength. So soil concrete proportion 10% steel or silts or clay, 30% gravel, and 80% cement stabilizer give the best mix proportion and the best strength for the soil concrete wall. So then we look on to build a mock-up house. These are the steps. We are used the same material that were excavated in this site. It is a good mixture of soil. This is how we are mix soil and cement. That is very easy method, like what we are. It's similar like concrete mixing, manual concrete mixing. No need advanced methods. So you can see the mix here, and the application very easy. We can handle it very easy. And compaction, it's really need a light compaction effort, not like ram earth. Ram earth is very difficult to compact. And this is the finish, walling finish. You can see smoother finish we can get. This will reduce the plastering and the painting requirements. So we are built up to 8 feet long wall. So this is the final product. This is exposed to the weather conditions. Still this wall remain in good condition. This was built in the 2019, nearly 1 year exists. So the advantages of the system, we can reduce the wall cost and introduce for the housing constructions. Lateral soil can be used as a sustainable material for the method. Fair finish construction through slip form can reduce the plaster and finishing cost. Parallel action of MEP, mechanical, electrical, plumbing installations, will cut down the further cost. And similar to the concrete mixer, we use gravel and different size of particles. So that will reduce the soil, what you call sand and metal usage in the industry, because we are using soil. Thus, it can reduce the sand mining effects, sand and metal mining effects, and the damage to the environment. As a conclusion, the study recommendations: the soil concrete proportion 10% fine, 30% gravel, and 80% cement stabilizer with high viscous flow. And using light compaction method, we can recommend this one for rural housing sector requirements with low cost and affordability, and reduce carbon footprint and environmental degradation due to the industry. Thank you very much.